What is server? A server is a device or computer program that provides services to other computer programs or devices, known as clients, in the same or other computers. It can also refer to a computer program that provides services to other programs on the same computer. A server typically provides resources, such as files, devices, services, databases, and other applications and programs, to other computers and users connected to a network. Types of servers. Web server, a computer system that hosts websites. Application server, a server that hosts applications. Database server, a computer system that stores and manages data. File server, a computer system that stores and shares files. Mail server, a computer system that sends and receives emails. FTP server, a computer system that allows users to upload and download files over the internet. Streaming server, a computer system that streams media files to clients. Virtual server, a software-based server that runs on a virtual machine. 9. Proxy server, a computer system that acts as an intermediary between two other computers. 10. Game server, a computer system that facilitates online gaming. What is serverless computing? Serverless computing is a cloud computing execution model in which the cloud provider runs the server and dynamically manages the allocation of machine resources. In this model, the cloud provider provides a platform that allows customers to upload their code, and the cloud provider dynamically provisions the resources needed to run the application code. The customer does not need to provision, scale, or manage any servers. What is data center? A data center is a physical facility that houses computer systems and associated components, such as telecommunications and storage systems. It generally includes redundant or backup components and infrastructure for power supply, data communication connections, environmental controls, for example air conditioning, fire suppression, and various security devices. Types of data centers. Traditional data centers, these are the most common types of data centers, typically located on site and used to house physical servers and other hardware. Cloud data centers, these are virtual data centers hosted off-site by a third-party provider, such as Amazon Web Services or Microsoft Azure. Colocation data centers, these are data centers that are leased by businesses to house their own servers and other hardware. Edge data centers, these are smaller data centers located at the edge of the network, typically used to process data closer to the end user. Hybrid data centers, these are data centers that combine on-premises and cloud infrastructure to provide a more efficient and cost-effective solution. Server virtualization. Server virtualization is the process of creating multiple virtual servers on a single physical server. It allows IT administrators to increase the efficiency of their data centers by reducing the number of physical servers they need to manage. Storage virtualization. Storage virtualization is the process of combining multiple physical storage devices into a single virtual storage pool or array. This allows IT administrators to access and manage storage resources from a single interface and make better use of their storage capacity. Network virtualization. Network virtualization is the process of combining multiple physical networks into a single virtual network. It allows IT administrators to create virtual networks that span multiple physical networks and manage them from a single interface. Disaster recovery. Disaster recovery is a set of processes and technologies used to ensure that data centers can recover from any disaster or outage. It includes backup and restore solutions, data replication, and cloud-based disaster recovery services. Cloud computing. Cloud computing is the delivery of on-demand computing resources over the Internet. It allows IT administrators to access and manage computing resources from anywhere, at any time. Software-defined networking. Software-defined networking, SDN, is a network architecture. Financials of data centers. The financials of data centers can vary greatly depending on the size, sophistication and location of the facility. Costs can include capital expenditures, CapEx, for construction, equipment, and any required technology upgrades, as well as operational expenditures, OPEX, for power, cooling, maintenance, staffing, and other operational costs. Data centers also require ongoing investments in training and technology to ensure the security, scalability, and reliability of the infrastructure. In addition to these costs, data centers incur costs associated with compliance and licensing. Depending on the type of data centers, there may be additional costs associated with disaster recovery, insurance, and other business continuity measures. In general, data centers are expensive investments, but they can provide a significant return on investment, ROI, due to their ability to store, process, and distribute data quickly and securely. They can also reduce operational costs by providing more efficient and secure access to data, as well as lower energy and maintenance costs. Future of data centers in India. The future of data centers in India looks bright, as the demand for data center services is expected to continue growing in the country. A number of factors are driving this growth, including the increasing adoption of cloud computing, the proliferation of internet-connected devices, and the rising number of businesses and organizations relying on data centers for their operations. One trend that is likely to shape the future of data centers in India is the increasing focus on sustainability. Data centers are known for their high energy consumption, and there is growing pressure for them to reduce their carbon footprint. This is likely to lead to the adoption of more energy-efficient technologies and practices, such as the use of renewable energy sources and the implementation of energy-saving measures. Another trend to watch is the increasing use of edge computing, which involves bringing data processing and storage closer to the point of data collection, rather than relying on central data centers. This can help reduce latency and improve the performance of applications, and is particularly useful for IoT, Internet of Things, and other real-time applications. It is likely that data centers in India will increasingly incorporate edge computing capabilities in the future. Overall, the future of data centers in India looks bright, as the country continues to experience strong demand for data center services and adopts new technologies and practices to meet the needs of businesses and organizations. Video by Satish R. Bansal.